Hi guys, hope all doing good. As an engineering student, have you ever struggled to understand the concepts or understand the given geometrical features in a question and present that on a drawing sheet in the engineering drawing subject? Or as a personnel of manufacturing department in a particular firm, have you ever found it difficult to understand engineering drawing and produce a particular product? At least have you felt that if you had a basic understanding of engineering drawing subject, you could have excelled well in your career? So yes, here is the solution for you all. So hi, I am Ravi Kiran Akilla. Being a GATE qualified instructor and also having an experience in a steel processing industry, I am in a position to teach you the concepts of mechanical engineering with a practical approach. I own a blog, the Engineers Gurukulam, with the link for which has been presented there, which you can see it now. Now, before going into the details of the subject, let me take you through a few sub-assemblies. These are sub-assemblies of a particular two-wheeler, and in this case it is Royal Enfield. This one is engine, this one is fuel tank, this one is a fork, front fork actually, and this is a suspension, in specific rear suspension. Now, these are all sub-assemblies. By that term, I meant to say they are made out of two or more components themselves. And such sub-assemblies all coming together, along with some other sub-assemblies which I didn't mention here, come together and form this bike, Royal Enfield. Of course, here this tire or this wheel is missing, but anyway, including that, when you say this complete thing become a bike. Now, before manufacturing this is actually manufactured by a manufacturing engineer. Every component is manufactured, might not be in the same industry, might be these components have been manufactured in different industries, but they are assembled together in a single industry. But while manufacturing them in those particular firms, those manufacturing or production engineers should have proper detail of the components. What should be its length, what should be its width, if it is a shaft or cylindrical thing, what should be its diameter, what should be the surface finish, what should be the surface shape like that of this tank, what should be the curve of this seat, what should be the radius of this wheel, etc, etc, etc. Until and unless the manufacturer or production engineer don't have those details, he cannot manufacture it. And we know that these designs are the imaginations of a designer who, keeping in mind the marketing aspects as well as that means aesthetics, economical viability, and also the strength and safety perspectives for functionality, all these concepts have to be there in the mind of a designer. After in conceptualizing those things into a beautiful design, he has to communicate it to a production engineer so that he can put that that imagination into a realization. Now, let me take you through another diagram or another picture here of a house being constructed. Now understand, when a building planner tells site engineer of his idea on a rough paper with a rough sketch, do you think the site engineer or construction engineer can build that properly with all the features as it is, as that planner have thought of, with the same dimensions, same geometry, everything? No, he will fail. Why? Because as a site engineer, he will be expert in manufacturing things once he has given instructions with a proper detail. And what do you think the details are? For example, in this house example, what should be the width of this, and from this end at what distance this door has to be built, at what distance this window should exist, what are the dimensions of the windows for these trusses or these bars and beams, all those structures, elements or those parts, what should be the distance between each offset of each element one after the other in horizontal fashion and in vertical fashion, what should be the angle here. All such activities should be noted down. All these design things should be noted down by designer onto a paper in a proper format, so that by looking at that format, site engineer need not consult the designer each and every time he gets a doubt. He just looks at that diagram or that paper and he understands what he needs to do to conceptualize, to bring that conceptualization of a planner into the actual realization in front of our eyes as a real building. Now, what do you think these all are? I'm talking about the diagram in this case, and that particular putting that onto a paper, the dimensions, the geometrical features. What I am talking about is engineering drawing. When a designer puts all his thoughts as an engineering drawing, this engineering drawing is understood by a particular production engineer, and then he starts producing the things. The name may change for the engineering drawing, but the theme will be same. Either it's a construction or it's a production, whatever it is. Even in other disciplines of engineering as well, names may change, but theme is same. This engineering drawing serves as a common language for engineers, from a designer while putting up his imaginations to a production or construction site engineer, and it's also used by a service engineer as well. This common language serves as a common platform of understanding and enables the communication between different departments of a firm or industry in regard to a particular product or output. A marketing engineer, by looking at it, can say what is the taste of the customers at present, and does this design satisfy that taste or not? Will the customers buy it or not? That inputs can be given by him. When we give that in terms of bill of materials, that BOM we call it, so in terms of that, when we give it to a purchase engineer, he will be able to understand the pricing of all those, or the cost of all those sub assemblies, the components, everything, and the cost of labor to assemble that product, and compare it with the existing market conditions, and can assess whether it is profitable or viable or not, depending on which the management can take decision to go ahead with the design or do some modifications or completely lay off the design. So engineering drawing has wide uses in the engineering field. So let us study this engineering in different volumes, because everything can't be covered in a single volume. So in the volume 1, I will be teaching you 2 units. In the first one, as an introduction, I will be describing what are the tools that are required, the basic tools. Of course there will be many, but the basic ones without which we can't draw or go further. So those basic tools will be stated and the basic use of them. Now then we will study the construction of regular polygons. Then we will go for construction of engineering curves, say parabola, ellipse and hyperbola, discuss something about the tangents, normals to those curves. Then construction of cycloid and involutes, then the scales, specifically vernier and diagonal. Then we will go to the orthographic projections, the reference lines. We will discuss few things about reference lines and their importance. Then we will discuss the projection of points in various quadrants. Then we will learn the projection of straight lines, if the line is inclined to both, parallel to one and perpendicular to one plane. So we will discuss about planes, quadrants, and then based on that we will discuss about projection of a straight line, and then determine true length and angle of inclination. So that is all for this volume 1. In the volume 2 we will continue with projection of planes and projection of solids. So for this volume, these 2 will be the syllabus. So be with me and get the benefit out of this course. Thank you.